Okay, so we're starting the last thing about integer exponents. The last video about that, and hopefully we're going to get scientific notation on this same video. Let's see what happens. So for the moment, since I don't know about scientific notation yet, if I'm going to get it on, let me let me just call this integer exponents, and we're going to call it D. It's the fourth one. And we should be finished. Now for a warm-up, before my last big problem, which is a little bit of a harder problem, a little bit more complicated, let's do a little warm-up first. What if you had, I'm just going to call it A, what if you had negative 3 to the fourth power? Negative 3 to the fourth power is 4 copies of negative 3. Negative 3 times negative 3 times negative 3 times negative 3. Okay, what's negative 3 times negative 3? It's 9. Positive 9. Negative times negative is 9. Go over your sign numbers if you're rusty, please. It's crucial to get that straight. Another negative 3 times negative 3 is another 9, positive 9. Negative times negative is 9. 9 times 9 is 81. It's going to be equal to 81. Okay, let me continue. What if I asked you negative 3 to the negative fourth power? Well, that would be, remember what x to the negative fourth power is? 1 over x to the 4. So the same thing over here. This is going to be 1 over negative 3 to the negative 4 power. I'm sorry, I apologize. 1 over negative 3 to the fourth power. To the fourth power. Let me repeat that. Whenever I make a mistake, I mix you up. I'm sorry. X to the negative 4 is equal to 1 over x to the 4. Negative 3 to the negative 4 is going to be 1 over negative 3 to the positive fourth power. What's negative 3 to the fourth power? We learned it already. It's 81. Negative 3 to the fourth power is 81. So this turns into 1 over 81. Okay, that's a warm-up for our big problem coming up right now, so that you won't get confused when you see these numbers on the big problem. All right, so number one problem, the last problem, I believe, in integer exponents that we got to do, and it's a big one, pretty big one. It looks like this: negative 3 to the x, negative 3x, not to the x, negative 3x to the negative fourth power, multiplying 4x to the negative 2 power, followed by y to the 3, sorry about that, y to the 3, needed to be inside the parentheses, and then the third power. There we go. Okay, so let me read that to you again in case you can, it's not so bad. Negative 3x, negative fourth power, then in parentheses, 4, x to the negative 2, y to the 3, and to parentheses, third power. All right, so we got our hands full over here. Step 1, this negative 4 right over here is going to apply to all members. There's only 2 members inside the parentheses. This positive 3 power is going to apply to all 3 members inside its parentheses. All three members. Okay, so negative 3, this negative 3 is going to be taken to the negative fourth power. We're breaking it down, right? That's my first move. This x is going to be taken to the negative fourth power. All right, x to the negative fourth power. This 4 is going to be taken to the positive 3 power. This x to the negative 2 is going to be taken to the positive 3 power. And this y to the 3 is going to be taken to the positive 3 power. Right? This 3 power belongs to all its members. This member, and this member. And this negative 4 belongs to this member and this member. There they are. Right over here on the right-hand side. Okay, what is negative 3 to the negative 4 power? We just learned about it. We just checked that out on scrap paper. It's going to be below, there's going to be a line here. And this negative 3 to negative 4, it's going to turn into 1 over 81. Right? It's going to turn into negative 3 to the fourth power on the bottom. Negative 3 to the fourth power is 81. We did the work up here. We preliminary work to show that. What about x to the negative 4? Where's x to the negative 4 is going to show up? X to the 4 is going to show up right over here. X to the negative 4 is 1 over x to the 4. X to the negative 4 is 1 over x to the 4. What about 4 to the third power? Is that going to show up on the bottom? Not at all. There's no negative here. 4 to the third power is 64. 4 times 4 times 4 is 64. It's going to show up on top, right? 4 times 4 times 4. 4 times 4 times 4, scrap paper, is equal to 64. What about x to the negative 2, right over here, coming back, right over here, x to the negative 2 to the third power. That's x to the negative 6, right? That's going to be x to the negative 6. What is x to the negative 6? It's 1 over x to the 6th. So I did 2 and 1, right? I don't always do 2 and 1. I usually do 1 step at a time. I just did 2 steps in 1. Let me repeat what I just did. What is x to the negative 2 to the third power? Power to a power. It's x to the negative 6. What's x to the negative 6? It's 1 over x to the 6th. And finally, y3 to the 3 is y9. It's not going anywhere. It's not going below the line here because everything's positive. So it's upstairs. Okay, we've got everything ready. These are all multiplying each other. Multiplication, multiplication, multiply. I could put a dot in between, but I don't think I have to. What's left standing on top in the numerator? The ones I don't care about, they don't do anything. The 64 and the y9. What's standing on the bottom? The 81 makes it in the end, and x4 times x6 is x10. And here is our final answer. That is the big problem, and we have done it. The problem is over. Okay, now, we have some more time on this video. It's not going to take long, the next topic. Let's see if I can get it on the video. If I can't, I'll just have to move it to another one. Next video, there's nothing I can do about it. All right, here is the topic. It's also part of your review. It's called Review 2 in your book. It has to do with homework 1, everything that we're doing so far on your Alex. And what we're talking about over here is scientific notation. Scientific notation. Okay, let me show you 2 classic examples of scientific notation. I don't want to overdo it because I'm afraid of going over 15 minutes on this video. So let me show you 2 classics. What if you have, here's problem number 1, scientific notation. It's not going to take long to put this topic. We'll see if we can do it on one video or we got to go to the next. Let's see. If you have 230 billion, and you don't want to write all those 9 zeros, 230 billion. There is something called scientific notation which lets you do it in a much summarized version. Let me show you what I mean. What are significant numbers that are non-zero numbers? There's only 2 of them, 2, 3. So you write 2.3. Always put the decimal right after the first digit on the left. Decimal always goes onto the first. If there were 17 digits here that were non-zero, it would always go right after the first one on the left. Then you multiply it always times 10. Now, is this a big number or a small number? This is not a 0.0005. This is 230 billion. It's a big number. So you multiply this by a certain exponent. Let me show you which exponent it is. 2.3, right? Start over here and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Where did I start from? Where the point is. 2.3. I counted 11. I put the power 11 next to the 10, and here is scientific notation, short form of 230 billion. Let me show you problem number 2. What if you have a tiny number? Let's say you have 0.10203040, and then you've got another 5060, followed by a 2. And you wanted to do a small version of that. You wanted to do not with all those zeros, and you want to put it in scientific notation. So there's only one significant number, so you write 2 over here. Then the times 10, that's always true. Times 10 was over here, times 10 over here. But now it's going to be a negative exponent because it's so small. So how do I figure out what the exponent should be? This starts with a 2, right? And the decimal point, the invisible decimal point is right here. Here's the visible decimal point. Start over here. 1, 2, 3, 4, 5, 6, 7. I reached the decimal point. It's 7. There's 7 digits to get to the decimal point. You put a 7 next to the minus here. And here's the scientific notation for a very small number. And we might be able to do 2 more and we finish this topic. What if I put, here's the next problem. Problem number 3. And I write 1.36 times 10 to the 7, and I ask you to change the scientific notation into a regular number. So it says 7, it says 7 here next to the 10, right? So then, right after the 1.36, you move the decimal place. Right after the 1, you move it 7 digits. 1, 2, 3, 4, 5, 6, 7. And you fill all of them in with zeros. So this becomes 136. How many zeros do I put in? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And that's how you turn it into a regular number. So you have a total of 5 zeros to the left of the 136. So it's here's 1,000. It's going to be 13,600,000. And the same thing with if you're going the other way. Let's say you got to turn you have 3.9, number 4, 3.9 times 10 to the negative 3 times 10 to the negative 3. So you're moving this where you want to make this really small, right? So then instead of going to the right, you're going left. So you go 1, 2, 3, 4. How many zeros do I have here? I have 3. 1, 2, 3, followed by 3, 9, and my decimal place is here, and I got 0. I'm sorry. How did I say 3 places? 1, 2, 3. 3 places. I'm trying to quickly do this before I run out of time. So I only have 2 zeros to fill in. So it's 0.0039, and that's how you change scientific notation into a regular number. Let me stop this quick. I think I got my 15 minutes in.